Hello again. In this video, I'm going to go over the third objective from section R6, which is about multiplying and dividing rational expressions. Okay, so let's look at multiplying rational expressions first. So you can see in this example, I've got a rational expression times another rational expression. Now you may think that multiplication is sort of the most important operation here, but I do want you to be aware that you do have division signs in this particular problem because you have rational expressions. A rational expression is a polynomial divided by a polynomial. So not only is there multiplication here, but there's also division going on as well. And we're actually going to take advantage of that. And the reason we're going to take advantage of that is because it could be the case that there's things on the top in the numerator that cancel with things in the denominator on the bottom. And so if that's the case, we would like to cancel those out as soon as we can to make this problem a little bit simpler to work with. And so that's actually how you should approach these problems where you're multiplying rational expressions. You should focus more on the division and less on the multiplication. Okay, so what we're going to do is we're going to look to see if anything cancels out first under the division signs. Okay, and the only way we're really going to know if there's something in common on top and bottom, a factor that's common on top and bottom, is to actually factor this first. So what we're going to do first is factor. Okay, and so I think the point I'm trying to make here is that when you're multiplying rational expressions, really what you want to do first is factor everything and look to see if anything cancels across the division sign. And then you can worry about multiplying after that. Okay, it just makes things a lot easier if you can see what cancels out before you start multiplying everything together. And so that's what we're going to do first. And that's probably what you should always do first. We're going to factor and then look to cancel any factors that are in common with the top and the bottom. Okay, so starting with the 2xy, that doesn't factor because there's only one term. Now down here, we're going to factor this. The first thing you should always do is pull out the greatest common factor, which in this case appears to be x times y. And you're left with an x here, and then a 3 here. Okay, now this is a trinomial. First of all, there's no greatest common factor except 1, so there's nothing to pull out of these three terms. But then you're left with a trinomial, but it's an easy trinomial because it has a leading coefficient of 1. Okay, and so we just need to look at the factors of 9. Actually, two factors of 9. That sum to the middle term, which is 6. Okay, and so let's just go through this systematically. So it could be 1 and 9, but that adds to 10. And then 2 would be the next number to look at, but 2 is not a factor of 9. So then the next number would be 3. So 3 times 3 is 9, but then that adds up to 6. And that's what we wanted to add up to. Okay, so this looks like it factors into x plus 3 times x plus 3. By the way, this is a perfect square trinomial, so you could also use the formula for the perfect square trinomial to factor. Okay, and then on the bottom here, the first thing is to pull out the greatest common factor, which happens to be a 4. And when you pull a 4 out, you're just left with x plus 3. Now notice we do get some cancellation here, right? This x plus 3 cancels with this x plus 3. And then I'm going to go ahead and multiply now, okay? So this is the first time I'm actually performing multiplication. Now one thing I want you to be aware of, when you have two fractions multiplied together, say something like this, you can multiply the tops first and then multiply the bottoms, and then divide those two numbers, right? So this is the same as 6 over 35. So I can do that here as well, right? I can take the tops here, which is 2xy and the x plus 3, and multiply those together first, and then multiply the bottom, these together, xy times x plus 3 times 4, and then divide those numbers. It's the same thing. Okay, and it's kind of preferable to write it like this because you have one division sign, and it makes it clear that anything on top that's in common with anything on the bottom will cancel out. So this x plus 3 and this x plus 3 do cancel out. Okay, now you could have done that here as well, but I'm just rewriting it like this to make it perfectly clear that these do cancel out. Okay, by the way, the x's cancel out, and so do the y's. And so it looks like you're just left with 2 divided by 4. Okay, and I really should have factored this 4, right? We're going to factor everything. We should have factored everything, including the 4, and the 4 factors into 2 times 2. And that way you can see that this 2 on top cancels with one of the 2's on the bottom. Now, by the way, when something cancels out, you're actually left with 1, right? I didn't need to do that here or here, but 2 divided by 2 is equal to 1, right? 1 over 1, technically. It's important that you put the 1 on top, though, because that's the only thing remaining, okay? So there is a 1 left on top. It's not so important to put the 1 on the bottom because 1 times 2 is simply 2, okay? But you do need to make sure you put the 1 on top since it's the only thing left. So this is really 1 over 2. And that's it. So I didn't do a lot of multiplying here. Mostly what I did was factoring and then canceling things on the top and the bottom that were in common. Okay? So oddly enough, when you multiply rational expressions, you're not doing a lot of multiplication. You're not doing a lot of multiplying. You're doing more factoring and canceling factors that are in common on the top and bottom than anything else. Okay? So keep that in mind when you run into these kind of problems. Your first gut instinct should be to factor things and try to get the factors to cancel that are in common on top and bottom. Okay, let's look at one where you divide rational expressions. Okay, so here we're dividing this rational expression by this rational expression. And so the way we're going to approach this is not that different than the way we approach dividing fractions. So say you had 3/4 divided by something like 7/5. Okay, you may remember that what we usually do here is we flip and multiply this bottom fraction. So if we flip it, its reciprocal would be 5/7. And then we're going to multiply by that. So you flip this and you multiply by it. Okay, and again, like I mentioned before, you can actually multiply the tops and the bottom and then divide. So this is the same as 15 over 28. Okay, we're going to do the same thing here. So I'm going to flip this and then multiply by it. Okay, so multiply by the reciprocal of this fraction here, and that's the reciprocal. Okay. Now, it's pretty much the same thing we had before in the previous example where now we're multiplying two rational expressions. But we're really not going to do a lot of multiplication here. We're going to do the same thing. We're going to factor and look to see what cancels on the top and the bottom. Okay. All right, so let's start with this. Greatest common factor is 1, so there's nothing to pull out. But this is the difference of cubes. Now remember the difference of cubes, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Okay, and in this case, a is the cube root of x cubed, which is just x, and b is the cube root of 8. All right, sorry, this should be cube root. Okay, cube root of x cubed is x, and then the cube root of 8 is 2. Okay, and so this should factor into x minus 2, x squared, and then x times 2. And I'm going to change the order of multiplication and call it 2 times x. Order doesn't matter when you multiply. And then b squared, so 2 squared. But 2 squared is just 4, so I'm going to write that as 4. Okay, so that's how this factors. And now below it, let's factor that. Now that's a binomial, and it happens to be the difference of squares. Now remember, the difference of squares factors into a plus b times a minus b. And in this case, the square root of 4 is your a, so that's 2. And then the square root of x squared is your b, which is square root of x squared is just x. Okay, so this is going to factor into 2 plus x, 2 minus x. Okay, and then times, now we're going to factor this trinomial. By the way, there's nothing in common except 1. Okay, but this is an easy trinomial because the leading coefficient is 1. And so we just need to look at all the factors, or 2 factors of -6 that sum up to -1, right, which is the middle term. Okay, so let's just go through this. 1 and -6, but that adds up to -5. 2 and -3, and that adds up to -1. Okay? Okay, and that's what we want. So this looks like it factors into x plus 2 times x minus 3. Okay, and now let's factor this bottom one. Okay, so first start with the greatest common factor. So it appears to have a 3 in common, so let's pull that out. And you're left with x squared plus 2x plus 4. And then this is a trinomial with the leading coefficient of 1. And so we need to look at all the factors of 4, or 2 factors of 4, okay, that add up to the middle term, which is 2. Okay, so 1 and 4, but that adds up to 5. Then you have 2 and 2, that adds up to 4. And then I guess you could look at the next one would be 3, but 3 is not a factor, so then you would go to 4, and you'd have 4 and 1, but that adds up to 5. None of those equal the middle term. And I guess you should check the negatives, but if you check the negatives, all right, -4 times -1 times -4 would add up to -5, and that's not the middle term either. -2 and -2, that adds up to -4, so that doesn't work. And then -4 and -1 adds up to -5, so that doesn't work either. So if you go through all the possibilities, all the factors of 4, none of them add up to the sum of the 2 factors of 4 never add up to 2. So this doesn't factor. Okay. Okay. So that doesn't factor. Not every trinomial factors. Okay. And the way you'll know it doesn't factor is when you exhaust all the possibilities here and none of them add up to the middle term. which is the case here. Okay, now remember, I said that you could, when you multiply two fractions together like this, you can multiply the tops first and the bottom and then divide. So I'm just going to do that. You can multiply everything on top and then multiply everything on the bottom and then just divide those two things. Okay, so I'm just going to do that here. Okay, and rather than rewrite all this, right, you can just simply do that, right? This right now is the same as that. And the reason I like that, I prefer you to write it like this, is because there's only one division sign. And so there's one stuff on top, a whole group of things on top, and a whole group of things on the bottom. If you have anything in common on top or bottom of this one division sign, then they'll cancel out. Okay? So let's see if anything cancels out. See this x plus 2 right here? If you rearrange the order of this, right, the order here doesn't matter because it's addition. This is the same as x plus 2. And so this cancels with this. X squared plus 2x plus 4, that cancels with this x squared plus 2x plus 4. So those cancel out. And then you're left with this. Now be careful, x minus 2 and 2 minus x are not the same thing. Okay, x is positive here, and then the 2 is negative. Down here, the 2 is positive, and the x is negative. So they differ by a minus sign, and we've run into that before. So what you want to do there is factor a negative out of one of these. Doesn't matter which one. I'm going to factor it out of the bottom. Okay, so let's go and do that on the side. So I'm going to take 2 minus x, and I'm actually going to write it like this, 2 plus negative x. Subtracting x is the same as adding negative x. And I'm actually also going to write the 2 as negative 1 times negative 2. That's equal to 2, right? Negative 1 times negative 2. And then I'm going to write this negative x as negative 1 times x. Negative 1 times x is still negative x. But the reason I'm doing that is so I can factor out this negative 1. So I'm going to factor that out front. And you can see that I'm left with a negative 2 here, right? Because I'm factoring this negative 1 out. I'm left with this negative 2, and I'm factoring this negative 1 out, so I'm left with x here. Okay? And then you can change the order of this. And you could actually write the x first. So I'm going to erase this so I have more room. So you can change the order of this, and you can write it as x plus negative 2. The order in which you add doesn't matter. Which, by the way, is the same as x minus 2. Okay, so when you factor a negative out of this 2 minus x, you're left with an x minus 2 inside of it. Okay? So let's rewrite all this. So you have x minus 2 on top, and that's it at this point because everything else canceled out. And then on the bottom, you're left with this, which is the same as this. Negative 1 times x minus 2. Right? Those are the same thing. 2 minus x is the same as negative 1 times x minus 2. And then you still have this 3 here. Okay? And so by factoring a negative out of here, right, I made it the same as the one on the top. They're both x minus 2. And now those cancel out. And by the way, you're left with a 1 on top, right? Because this cancels to 1 over 1. Okay? So don't forget to put the 1 on top. All right, and so to finish this off, it looks like you get 1 over negative 3. Because negative 1 times 3 is negative 3. which by the way is the same as negative 1/3, which by the way is the same as negative 1 divided by 3. You can put this minus sign on the bottom, in front, or on top. It's the same thing. Okay? Okay. So that's it. All of this, after you divide these two rational expressions, you're left with negative 1/3. Okay? So once again, I want to emphasize this. We did not do a lot of dividing here. Well, we did do a lot of dividing, but the first thing we actually did was factor. Okay, so when you see these rational expressions that you're multiplying or dividing, your first gut instinct should be to factor everything to see if the factors cancel, right? If there's something in common, a factor on top in common with a factor on the bottom, they'll cancel out. And that's what you're trying to achieve by factoring this. You're trying to find common factors that cancel out. And that is when you're dividing, right? When you're canceling this out, you're really doing division, okay? But you won't know if you have factors in common until you factor everything. So your first step should be to factor everything in the hopes of having some of those factors cancel out across the division sign. Okay, so I hope you found this video helpful. Okay, thank you for watching. Bye-bye.